Hello and welcome to the second part of Introduction to the new IBM Z17 mainframe computer. The mainframe experts at the European Mainframe Academy further analyzed the 3 Redbooks concerning the IBM Z17 hardware and connectivity. In the first part, we discussed networking and we talked about storage and how to connect. What about clustering? If we want to connect multiple Z17 or older machines together for even greater resilience and scalability, then a parallel sysplex or even GDPS configuration is needed. We must observe the N-2 rule. That means if a Z17 is installed in a sysplex environment, it can work together with Z16 and Z15 computers. Z14 will then no longer work. In this sample configuration from the Connectivity Redbook, we see on the left side a Z17 with some ZOS LPARs and an internal coupling facility, a Z15 serving as a dedicated coupling facility, and on the right side a Z16 with additional ZOS LPARs. The N-2 rule is observed. If we configure it within a data center, we can use the Integrated Coupling Adapter Short Reach, ICA-SR 2.0, that supports up to 150 meters and timing connectivity direct to the CPC drawer. The Coupling Express 3 Long Reach connect into the PCIe I/O drawer for longer distances between computer centers. Supported are unrepeated distances of up to 10 kilometers or up to 100 kilometers over qualified DWDM services. Dense Wavelength Division Multiplexing (DWDM) is an advanced optical fiber multiplexing technology designed to increase the bandwidth and distance of fiber optic networks significantly. It works by combining multiple data signals, each transmitted on a unique light wavelength, onto a single pair of optical fibers. This allows the simultaneous transmission of many separate data streams without interference, as each stream is carried on its own distinct wavelength. Next, let's get to the heart of the processing power, and let's talk about the processors and the memory. The Z17 is powered by the IBM Telum 2 processor. Each chip hosts 8 high-performance cores running at 5.5 GHz. Each core has a massive 36 megabytes of level 2 cache. That's a 40% increase over the previous generation. There's also a virtual level 3 cache with 360 megabytes per dual chip module, and there's an on-chip ring interconnect that connects everything together. To keep data as close as possible to those processing units, minimize any delays. That multi-level cache hierarchy is crucial for achieving high performance. The faster the processor can get the data it needs, the quicker it can execute instructions, and the on-chip interconnect provides an extremely high bandwidth pathway for data to move quickly between the different cores and the various levels of cache within that dual-chip module. The virtual level 3 cache acts as a larger shared pool, providing high-speed memory to further reduce the frequency of accessing the slower main memory. Each PU chip, and there are 2 of them on each, dual-chip module has 43 billion transistors. That's incredible, and it's just an astounding level of integration crammed into these tiny chips. This clock rate, coupled with the again optimized cache structure, translates into better performance for the most demanding transactional enterprise workloads. And last but not least, let's talk about main memory. The Z17 can accommodate up to 24 memory controller units. The maximum physical memory size is directly related to the number of CPC drawers in the system. Each CPC drawer can contain up to 14 terabytes of customer memory, totaling 64 terabytes of memory per system. The maximum amount of main memory you can define for a single LPAR or logical partition is 32 terabytes. That's a lot of memory and enough memory to hold an immense amount of data. As you can see, the European Mainframe Academy is always at the forefront of technology. Are you interested in mainframe training? You've come to the right place.